Welcome back everyone. This is the Q&A session 5 from the playlist of electromagnetic induction. The topic is magnetic flux and the Faraday's law of induction. And this is the question which I have taken for this session. This question is available in the NCERT book. But I have taken this question for this session because this question is based on the topic of magnetic flux and the Faraday's law of induction. And this question is primarily important for you from the point of view of the board examination. So here the question is, a square loop of side 10 cm and resistance 0.5 ohm is placed vertically in the east-west plane. A uniform magnetic field of 0.1 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to 0 in 0.7 seconds. So we have to find the magnitude of the induced EMF and the induced current during this time interval. Here the magnetic field has been decreased to 0 in 0.7 second at a steady rate. So here this is one square loop. And the length of the side of the square loop is 10 centimeter. So this is 10 centimeter, and this is the normal to the surface of the square loop. This loop is placed vertically in the east-west plane, and now a uniform magnetic field is set up across the plane in the northeast direction. So this is the northeast direction, like this. So this is the direction of the magnetic field B. This is the this arrow, this horizontal arrow is basically pointing is the normal to the surface of the square loop. So this angle will be equal to 45 degree, because the magnetic field is set up across the plane in the northeast direction. So this angle will be equal to 45 degree. So the angle made by the normal to the surface, made by the normal to the surface of the loop and the magnetic field is 45 degree. So first of all, now we will find the initial magnetic flux, which is given by the formula BA cos theta. So here the initial flux will be equal to the magnetic field is equal to 0.1 Tesla. The area of the square will be equal to this. I have to convert it into meters, so this will be equal to 1 by 10 meter into 1 by 10 meter. The area will be equal to 1 by 10 whole square into 1 by root 2, where this 1 by root 2 is the value of cos theta, because theta is equal to 45 degree. So here the initial flux will be equal to 0.1 divided by 100 root 2. So this is the value of the initial magnetic flux, which is equal to 0.1 divided by this 100 into root 2 Tesla meter square. And the final flux is 0, because this magnetic field is reduced to 0 in 0.7 seconds. So the induced EMF is given by the change in the magnetic flux divided by the time interval. Now the change in the magnetic flux will be equal to, this is equal to 0.1 divided by 100 root 2 divided by delta t, which is equal to 0.7. So this is equal to how much? This is equal to 0.1 divided by 100 root 2 into 0.7, or we can simply write this as 1 divided by 7 root 2 into 100. So the induced EMF is equal to, now 7 root 2 is equal to 1.414 into 7. So this is approximately equal to 9.9. The value of 7 root 2 is approximately equal to 9.9. So if I take it as 10, 9.9 is, I am just roughly taking it as 10. So this will be equal to 1 divided by 1000 volts. So the induced EMF is equal to 10 to the power minus 3 volt, and this is the approximate value. Induced EMF is approximately equal to 10 to the power minus 3 volts, and the induced current will be equal to induced EMF divided by R, and this is equal to 10 to the power minus 3 divided by 0.5. So this is equal to, this 0.5 can be written as 1 by 2, so this will be equal to 2 into 10 to the power minus 3 ampere. So the induced EMF is approximately equal to 10 to the power minus 3 volts, and the induced current is equal to 2 into 10 to the power minus 3 ampere. So thank you very much for joining this session, and the next session I will be now coming up with the topic of Lenz's law. So till then, have a nice day. Bye.